Hey guys, Professor Calculus is here with an interesting integral today. Before we go, make sure to like and subscribe as it is free and you can always change your mind later. So, how should we solve this integral? Actually, there's no elementary solution that we can solve this integral, and it is only solvable with Feynman's trick of integration. So what does the Feynman trick of integration says? It says that if I have a function like this that is not integrable, I can introduce a new parameter t in top here, and I should somehow change the form of this integral by taking derivative of this integral and differentiating under integral sign to be able to solve this integral. So how should we do that? Well, when I have a parameter here, I can differentiate with respect to this parameter, and I'm going to take the derivative, the ddt of I of t, which is equal to ddt of this integral right here, x dt minus 1 over ln x dx. Now, according to the Leibniz integration rule, I can move this derivative inside this at the condition that I should make this a partial derivative instead. Thus, it's going to be a partial t x to the t minus 1 over ln x dx. And what does partial derivative means? This curly little thing, it means that we should consider the x constant and just differentiate with respect to t. So this thing here is the constant of derivation, this minus 1 here, and this here. And just this thing we should differentiate with respect to. Thus, the I prime of t is the integral from 0 to 1, and the negative 1 is a constant, thus it's going to go away. The 1 over ln x is a coefficient, thus we're going to keep it as a coefficient. And I'm going to be having x to the t ln x over ln x dx. And notice how these ln x's cancel out. And my I prime of t is the integral from 0 to 1 of x to the t dt. Now, this integral is actually anything but a tough integral. And according to the power rule, the answer is x to the t plus 1 over t plus 1, the limit from 0 to 1. And if I put 1 to the t plus 1 over t plus 1 minus 0 to the t plus 1 over t plus 1. 0 to any power is 0. Thus this is going to go down to 0. And 1 to the any power is 1. Thus I can write it as just 1 over t plus 1, which is equal to I prime of t. Now we can reverse the whole process here by integrating. Integral of 1 over 1 plus t. The integral of this function, 1 over anything, is ln of it. Thus it's going to be ln of 1 plus t plus c, some constant of integration. And this constant here is important. So how should I find this constant? First of all, I'm going to write this integral itself, x to the t minus 1 over ln x dx, which is equal to ln of 1 plus t plus c. Now we want to see what happens if I let t be equal to 0. If I let t be equal to 0, what's going to happen? So I'm going to get c plus ln of 1 plus 0 equal to the integral from 0 to 1 x to the 0 minus 1 over ln x dx. Thus I'm going to have c plus ln of 1 is equal to the integral from 0 to 1 of 1 minus 1 over ln x dx, which is 0, and the definite integral of 0 is 0. and ln of 1 is 0, thus c is 0. Now I found my integral to be ln of 1 plus t. Now, if I put I here instead of t, if t equals to I, the imaginary number with the property that I squared is -1, I'm going to get x to the I minus 1 over ln x dx equals ln of 1 plus I. But how do we calculate ln of I plus 1? Well, ln of any complex number is given by the formula ln of absolute value of that number plus I, the arc of that number, which we're going to see what it is. So if I switch to the complex plane, this is imaginary and this is real, you'll see that if I want to draw it, the number complex of I plus 1, it's going to be, I'm going to move 1 unit in the real and 1 unit in the imaginary direction. Thus I'm going to be here, which is 1 and 1. And if I make it a little bit bigger, it's going to be 1 and 1 unit. And according to Pythagorean theorem, this hypotenuse here is root 2. 1 squared plus 1 squared square root of is root 2. And the magnitude of this complex number is root 2. And the arc here, which refers to the theta here, the angle here, is pi over 4, because the angle here is arc tan of 1, which is pi over 4. Sorry, this angle here is the angle here, because this is a special triangle, you're gonna get it to be pi over 4. So ln of 1 plus I equals 2 natural log of root 2 plus I pi over 4 plus 2 pi k, because this is periodic and we can extend it to k if k is an integer. And according to the logarithms, went down a little. According to logarithms, the property, I can move this power of half here. I'm going to say half ln 2 plus I pi over 4 plus 2 pi k. And thus I can write my integral x to the I minus 1 over ln x dx as half ln 2 plus I times pi over 4 plus 2 pi k. And that is the answer of my integral here. Thank you for watching this video. Please like and subscribe, and see you next video.